Hello everyone. Today we are going to introduce the basic concept of database systems. So for this lecture, I refer to some slides and lectures. If you are interested in other references, I recommend you try to access the following links. And I truly appreciate for Professor Sang-won Lee for sharing some slides. So in this class, we are going to study the basic concept of database systems. So before that, I would like to ask you the question, what is the database? So there are some, so you just choose one of them. A is a file that stores and organizes a large amount of data. B, an application to carry out bookkeeping tasks. And C, a file that stores your computer's configuration details. And D is a device used to store deleted files. E is none of the above. You can choose. Let me give you some seconds. Did you choose it? Did you choose the answer? The answer is A. It's okay. Please don't be frustrated if it was incorrect. We are going to study the definition of database. So the database, the meaning of database is a file that stores and organizes large amount of data. Okay. Here, the key concept is to store and organize the data. And B is related to some application for database systems. And C is related to the meta information for database. And D is a log file to recover your DB. So we are going to study these concepts later. So again, the database is a file to store and organize the data. So let me first define several key terms using this class. First, as I said, the definition of database is a collection of data, organized collection of data. And data, here the data means that a fact, some facts that can be recorded. It means that can be stored with implicit meaning. Here the most important concept is the data. The data is the facts to be stored for your objective. And we also define the database management system, which is one of the most important terms in this class. So we usually abbreviate the database management system as DBMS. Here, the definition of DBMS, actually this is a software system to facilitate the creation and maintenance of a computerized database. So once we store the data, we need to maintain the data. So to maintain the data, we need the database management system, DBMS. So we are going to study what DBMS means later. And last concept is database system. Actually, this is similar to database and DBMS. And database system is a software together. Actually, it includes DBMS together with data. So it is a DBMS plus data. Sometimes we also include some application for database and DBMS. Okay, this is a big concept, including DBMS, database, and application. So if you are not familiar with those concepts, it's okay. We are going to study these concepts in more detail. So first, let me explain what data is. As you know, the data exists everywhere. So when you collect the data, you can find a lot of data, different various sources. When you use the web, there are a lot of data. There are a lot of web documents. This is also data. And when you use some Amazon, some e-commerce such as Amazon or Naver Shopping, you can also find some product data. And when you use some account in bank, they also have some data. These are all data in business, using business. And when you can also create your data by yourself. So when you take a picture by your cell phone, you can also generate the data and you can collect the data. And when you upload some data via YouTube, this is also data. So you can just create the data by yourself, and you can also retrieve some data in the commercial application software. So we can access and we can generate a lot of data. And this is an example of some statistics, how many data exist. And this is some report. If you are interested in this report, I recommend you to access this link. This is a report by Domo. Okay, in 2016, they just make some statistics. Some interesting statistics is that Google translate about 70 million words every minute of the day. Surprise, right? And Americans use about 12 billion megabytes of wireless data. So by using wireless device, they just use 20 million megabytes every minute of the day. Very huge, right? And many students also use the Netflix. And Netflix subscribe about 70,000 hours of video. This is also very huge. So as you can see, a lot of data exists in different devices and in different applications. And this is another example. Data is also created by IoT, and average internet user just use 1.5 gigabyte every day, and autonomous vehicle also generate 4 terabyte every day, right? This is really huge, right? And connected airplane or smart car, cloud video provider also generate a lot of data every day. It means that the flow of data is coming every day. As I said, the autonomous vehicles also generate a lot of data. They just generate 4 terabyte every day. If we consider autonomous car, the size of data will increase. So to manage this huge data, we need another application, another system. How to manage this huge data? This is really big issue nowadays. To address this problem, many companies try to provide some service. So they usually consider big data. Actually, the big data is a buzzword. There is no formal definition, but people try to define the big data as 3V, including volume, variety, and velocity. Here, the volume means that the size of data, the scale of data, and variety is different types of data, including text, graph, and social media data. And velocity is related to real-time and online performance. We are going to study those three concepts of big data later. So anyway, as the big data emerges, we need to maintain. It is very important to maintain the big data. As I said, the data is also generated from social networks, mobile devices, and IoT. So a lot of data is generated nowadays. So now many IT companies try to store the data and provide some effective application by managing these big data. Some interesting thing is that actually the Netflix was the DVD rental service company, but nowadays Netflix is well known as online streaming service company. I think some of the students also use Netflix. Actually, this company is not related to IT, but nowadays many people just think this company is an IT company. And Amazon also similar. Amazon was an online bookstore company, but nowadays they focus on developing many IT techniques. So people just think Amazon is one of the biggest IT companies. It means that at the past time, some companies was not related to IT, but when they consider big data, they try to change the traditional service to new IT services. And nowadays, the people just consider them as their IT companies. This is also similar phenomenon is also happens over the world. And you guys already know the Facebook, Twitter, IBM, Google, Oracle, and Microsoft. They also related to computer, but they just focus on developing IT-driven services. In Korea, Naver and Kakao are also similar. They try to provide some service by managing big data. So to manage these big data, we need to think. We first define the database. I already asked the question, right? So database is defined as an organized collection of data. It's a collection of data to be stored. So there are a lot of examples in your daily life. A telephone book, this is also one of the databases. And papers in your cabinet, this is also databases. And files on your computer, this is also some type of databases. Once you collect the data, we just call them as databases. And Amazon Product DB and SKKU Student DB, they are also database. We have to collect the data. If in our university, we have to collect some data for students and improve some professor information. So once you store those data, another important functionality is to support data retriever. It means that after collecting the data, we want to find some related file as efficiently as possible. So we need to support efficient data retriever. Once we store the data, we just call them data. But if we want to find some meaningful data, we just call them information. So to find out some information, the supporting efficient data retriever is really, really important. So to store your data, you may consider different data types. So when you consider bookstore, you may need to store books, customer and pending orders history, and user preferences. So when you store those data, it's not enough to fit the memory. So it means that if the data size is huge, we have to store this data to the secondary data storage. such as SSD or hard disk. So to store this data to the secondary data storage, we also need another technique. We are going to study this technique later. And when we consider database, we also need some other functionality. So we may need to insert new information, new data on books, and you may want to delete some book information, and you may want to retrieve the data by author, title, and so on. This functionality is important. Actually, this is a fundamental functionality to manage your DB database. And if you consider your database is accessed by multiple users, you also need to support concurrency control. This is also very important for multiple users. And some data, when many users try to access the data, and supporting the privacy and recovery issue is also important. So you need to support consistency and recovery. So to support this functionality, we need another new software called Database Management System. Okay? The Database Management System, the DBMS, is a system software to store, maintain, and retrieve the data as efficiently as possible. It means that by using the DBMS, we can support these functionality. So there are a lot of DBMS nowadays. Oracle, which is one of the Oracle is the popular, one of the biggest company in DBMS, and IBM DB2, Microsoft SQL Server, they are also famous. They are common commercial DBMS. And PostgreSQL, MySQL, they are free DBMS. So if you want to use DBMS for free, I recommend you to use MySQL. This is really good to use. And MongoDB, this is one of the popular NoSQL. Actually, they are all related. They are RDBMS, relational DBMS. We are going to study what RDBMS is anyway, and this is another type of DBMS, so called NoSQL. So there are a lot of NoSQL DB, and MongoDB one of the popular NoSQL. So if you want to study NoSQL, I recommend to use MongoDB. And MariaDB is an extension of MySQL, so MariaDB is also free. And SAP HANA, this is an in-memory DBMS, and this is developed by Korea. Actually, this is developed by SNU, Seoul National University. So there is a research center in Seoul. Actually, SAP is one of the global IT companies, but HANA is HANA is a in-memory DBMS. The university just tried to develop in-memory DBMS, and they just merged with SAP. So their name is SAP HANA. And SQLite, this is for mobile DBMS. So if you are interested in mobile DBMS, I recommend you to use SQLite. And there are a lot of DBMS. And this is MS Access. So when you install the MS Office, you can also use one tiny DBMS system, DBMS. Okay, you can try to use the MS Access. So among a lot of DBMS, we can visualize the overall structure, overall concept of DBMS. So here is an end user. End user try to access the data. In the case, DBMS is a intermediate software. They just, if the user try to access, they try to find some data from the database and just return the data. And if you want to store new data, and they just ask to store new data to DBMS, and DBMS try to store the data to the database. So this is an intermediate software, intermediate system software. And you can also retrieve some data from DBMS. It means that if you want to access, if you want to store, maintain, and retrieve data, you don't need to access database directly. You just ask some request to DBMS, and based on DBMS, they can store the data, and they can maintain the data, and they can also retrieve the data. So you can just access the DBMS. You don't need to directly access database. This is cool, right? It means that you don't need to know the details in the database. You just try to access the database, DBMS. So let me more explain the typical DBMS functionality. As I said, you can define some particular database, including data types, structures, and constraints. You can just define these types, and based on this type, you can just ask to store the data, and DBMS just store the data. And you don't need to know the details in secondary storage medium. You can just ask to store data. Okay, very easy to use. And if you want to manipulate the data, you can also ask to manipulate the data to DBMS. If you want to find some data, you can just ask to retrieve the data. You can just ask to retrieve the data to DBMS. And you can also modify, including insertion, deletion, and update. You can just use the DBMS. And if we consider multiple users, actually this is really difficult to maintain, but by using DBMS, they can support, the DBMS just support the concurrency control. So you don't need to consider the details you don't need to consider whether multiple users try to access the database. By using DBMS, they can just control multiple users. This is really cool and very important functionality. This is the main reason of why we need to use DBMS. Without using DBMS, managing multiple users is very difficult. But by using DBMS, you can easily control multiple users. And you can also support the data concurrency and data consistency. Okay, and now let me briefly explain the history of DBMS. The DBMS was invented in 1962, and especially the 1963, the Charles Bachman just developed the commercial DBMS. And E.F. Code, he is also one of the famous guys in database community. He also developed the concept of relational database, and based on his concept, we just tried to develop the relational DBMS. And now the Oracle just developed one of the popular DBMS called Oracle. And many companies try to use the DBMS by using Oracle service. And many people just try to use, and currently, and still we just use the relational database, but the data type is a little bit different. In these days, the data types are based on the relational database, but as big data is coming, many different data types emerge. So here, just NoSQL NoSQL was developed. And another NoSQL Cassandra, this is also another NoSQL DBMS developed. And nowadays, many NoSQL DBMS was developed to maintain the different types of data. This is the overall history. So if you have a chance, I recommend you to use the Oracle DB. As I said, this is one of the popular commercial DBMS. And you can also try to use the MongoDB. This is also one of the popular NoSQL. Okay. In this class, we briefly cover Oracle NoSQL. So you try to use. Actually, there are a lot of nowadays there are a lot of DBMSs, but you cannot use you cannot use all DBMS. So you just use Oracle, MySQL, or NoSQL. They are representative DBMS. So let me simplify the database system. As I said, the user try to access the DBMS, and they usually use the application program. It means that they usually use some web service. By using web service, you can try to access the data. And here, when you access the data application, they try to process your request as queries. And there is some other software, and they try to request to access the stored data. This is over structure, over procedure to access the data in the database. Here we usually call these two software DBMS. So DBMS DBMS is in charge of processing and accessing the data. And including the application and database, we usually call database system, DB system. So DB system includes DBMS and database, as well as the metadata to store the data. And it also includes some application program. So this is the overall view of database system. Let me explain some example of database system. This example is to enroll a course. So you try to enroll the database course by using website, our SKK registration course website. It is basically, you can just, in the case, you try to access the website, and based on this interface, you can request to register the database course. In the case, the DBMS manage your request, and they try to access some data from database. And this is, as I said, this is a database system. So based on your interface, you can access database system. In fact, there are different types of DBMS, but in this class, we focus on studying relational DBMS. So we are going to study relational DBMS in detail. And we also call this structure as two-tier. This is an interface. This is another tier. So we usually call two-tier architecture. Okay, and now let me briefly explain the main objective of this course. I just explained the main concept of database systems, and I also define some important terms used in this class. And now let me explain the main objective of this class. The main objective consists of three parts: the database design, database implementation, and we will briefly cover recent advancement in DBMS. For database design, we are going to study data model and SQL. By using data model, we can design our database. So to design the data model, we are going to study relational model and ER diagram, entity relationship diagram. We are going to cover this database design. And to design the database, there are some anomaly problem. Some anomaly problem happens. To address this problem, we are going to study some important database theory, including functional dependency and normalization. And to use your DBMS, we are going to study some specialized language called SQL. This is a specialized language in DBMS, in database systems. But as I said, it is easy to use. So using SQL, you can store the data from database, and you can also retrieve the data from database. This is one part. And second part, we are going to study the database internal database structure, internal DBMS structure. So as the DBMS internal, we are going to study how we store the data and how we construct the index and how we optimize some queries. We are going to study the query processing. It means that given our user just specifies some SQL, and based on that SQL, we need to find some data from database. In that case, we need to understand how we find out, how we retrieve some data using DBMS. This is related to query processing. And to make the query processing more efficiently, we briefly cover the query optimization. It means that to process multiple query, we try to optimize the query structure, or we may need to consider how we differently find some information find some data from the database. This is related to query optimization. And if we consider multiple users, it means that multiple users try to access one DBMS, we need to control multiple users. This is related to transaction management, and we also need to consider concurrency control, recovery management, and isolation, so on. So this is very important topic. This is one of the important reasons why we use the database systems, DBMS. So we are going to cover transaction management. After that, we briefly overview the recent topics in DBMS. So in the previous part, we basically consider the relational DBMS. It means that the data is represented by some relations. Actually, the relation is similar to table. We just store the data as table. But as you expect, some data is a little bit hard to represent as table. In that case, we need to consider different types of data. Usually we call these different types of data semi-structured data or unstructured data. So to manage these different types of data, we are going to study NoSQL. And if the data size is really huge, we cannot store the data in one computer. So we need to consider distributed database. It means that we need to store the data in a distributed way, and we also need to process the data in distributed way. And Hadoop is one of the popular distributed data processing. So we are also going to study how we use the Hadoop. And if we have a time, we briefly study the concept of data mining and the concept of machine learning. Actually, recently the data mining is one of the important topics in the database community. So we briefly cover the concept of data mining. Again, these three topics consist of 5 different parts. The first part is related to foundation. So we briefly cover what the relational model is and how we use the SQL. Okay, this is the first part. This is foundation for database system. And you may need to design your database system by yourself. In that case, we are going to see how to design the database systems. So here we are going to study ER diagram, ER model, and we are going to study the database design theory, including functional dependency and normalization. And for the project, we also cover the database programming with web interface. This is related to your own project. So let me explain how we cover data and DB programming later. And this is a first chapter. So I guess before the midterm exam will cover these topics. Midterm exam will cover these topics. After that, we are going to study the database implementation. So how we organize file and how we build index, how to understand query processing and transaction management for multiple users. And this is related to concurrency control and locking principle. And the last topic is related to big data. So we are going to study Hadoop, NoSQL, data mining. Yeah. Personally, I'm very interested in these topics. Nowadays, these topics are very important. But due to the time limitation, we only cover some important concepts of big data and data mining. So if you are interested in these topics, just visit my office or try to consider the graduate school. Okay, this topic is really hot and interesting, especially to me. Okay, and I just briefly explained the basic concept of database systems. If you have some question about database system, you can try to access this link and write down your questions. I will give the answer, and you can also use the iCampus. Okay, thank you for listening, and I hope you have a good time. I hope you have it good for your understanding.